Hi guys. So I'm here to talk to you about weather models and how they are made, and perhaps more importantly, what we use them for. So models are used to predict everyday weather. This is where your forecast comes from. We get seasonal outlooks, like is this season going to be particularly dry or wet? We can get some information about climate change, some evidence about climate change. A lot of people will say, oh, well, we don't have evidence. We do have evidence because we can compare the models to the observed conditions. And then the last thing is that we can predict what tropical systems are going to do, like hurricanes, for instance. And so, how are they created? Um, so, models are a series of very complicated math problems, basically. And the information that we use for those math problems we gather from various sources in in a grid pattern. So here is you can see very small grids to very large grids. Divide the planet up into grid system. They are done latitudinally, which are the horizontal lines that go from east to west. Longitudinally, which are the ones that go from north to south, or the vertical lines. And then they are also, as you can see in this section that's pulled out over here, that they are also broken up by altitude. And so we have these varying grid sizes. They can be very large to very small. The smaller the grid size is, the more accurate of a picture we can get, just simply because there's more data. So you might be asking, what type of data do we use to put into these very complicated mathematical equations? And the type of data that we use might be wind speed and direction, heat transfer, radiation, relative humidity, surface hydrology, which is how the water is distributed at the surface of the planet, interactions with neighboring grids, meaning how are those data points related to the data points of neighboring grids, so grids next door to. And then the components of the air. So, what is the exact gas distribution? Are there any aerosols? And then dynamic vegetation refers to what happens. What we observe is that seasonally there are changes in the amount of carbon dioxide and oxygen available locally based off of the amount of photosynthesis or decay is occurring. So, for instance, in the fall, you have leaves that are dropping and beginning to decay, and they're not photosynthesizing as much. And so, you see an increase, a spike in carbon dioxide in the fall. And then in the springtime, it's the opposite. So, you have all this green, lots of photosynthesis happening, and then a lot of oxygen, or rather carbon dioxide, being converted to oxygen. So you see a drop in carbon dioxide in the springtime. And of course, we have to also look at the ocean currents. What are the oceans doing? Because the ocean is connected to the atmosphere at the horizon, right, at sea level. And then you also look at advection, which is the vertical movement of air from left to right, top to bottom in the air column. And so, where do we get this data from, even? There are multiple sources. The most common ones I've listed here is the weather stations, the land weather stations, such as what you see right here. This is a buoy or an ocean weather station right here. We get it from satellites. So, satellites are orbiting the Earth at a very high altitude. Um, and then we have weather balloons and radar. So this is radar right here, and this is a weather balloon. This is the radiosonde right here that's attached to a balloon. It goes up into the air column and it takes readings at various altitudes, and that's where we get the differing information for each altitude for those the sort of the air column grids that you saw on the first slide. So, who makes these weather models? There are about 30 organizations around the world that make weather models. They're the ones that we use most frequently to predict our weather here in North Carolina are the European model and the North American model. And the European model has a tendency to be a little more accurate most times. than the North American model or the GFS. And the reason is because Europeans, quite frankly, are more willing to spend money and time on developing their model. So, I was talking about the grid size, smaller it is, the more powerful the information that we get from it is. So that grid size is called resolution. So the smaller the grid size, the better the resolution, like the better picture we can get about what's happening with the weather. But the problem with that is the smaller the grid size, the more data points we have, the more calculations we have to make, the more computer power we need to make those calculations. Computers aren't cheap. The people that operate them aren't cheap. So it's pretty much consolidated resources. And that's one thing that we see in North America. You can see here that the US National Weather Service has more than 3 weather models that they're pouring resources in. So it's kind of like, in Europe, they put all their eggs in the same basket, whereas here, we're more likely to have different models, and each model differs based on, how it calculates different interactions within the atmosphere system, different interactions between wind speeds and different physical properties of the fluid of the atmosphere. So the great thing is that we have multiple models. We have upwards of 30 models that we can consult. And the cool thing about that is that if you have one model only and it gets it wrong, it gets the forecast wrong, well, then you're wrong, and you've put all your eggs in that basket, and that basket broke, and now all your eggs are broken. But if you have multiple different baskets and only one basket breaks, then maybe you lose 4 eggs as opposed to all of your eggs, right? So this gives us an opportunity to see a bigger picture of what the possibilities are. This weather model right here it was pulled from a website called literallyweathermodels.com, and they have really neat stuff if you want to look at different parts of the globe, if you want to look at different parts of the atmosphere, different altitudes, what's happening. It's just a neat thing to play around with. All right, so that's the basics of what weather models are and how we make them and what we do with them. And I hope that you have now a sort of basic understanding of what weather models are. Have a good night.